Hi guys, today we're going to learn about limits and their properties. Let's start with properties of limits. If you have that L, M, C, and K are real numbers and the limit when x approaches to c of f of x is equal to L and the limit when x approaches to c of g of x is equal to M, then what you have is first the sum rule. The sum rule tells you that if the limit when x approaches to c of f of x plus g of x, that's going to be equal to L plus M. In other words, what you have is you have the limit when x approaches to c of f of x plus the limit when x approaches to c of g of x. And this is always true if you prefer. Similarly, the difference rule tells you that if the limit when x approaches to c of f of x minus g of x is equal to L minus p, this is the same as saying the limit when x approaches to c of f of x minus the limit when x approaches to c of g of x. Okay? So, either way, this or this way would work. Okay, the third one that we have is the product rule. As the name tells you, this is talking about multiplication. So what you have here is the limit when x approaches to c of f of x times g of x, that's equal to L times n. In other words, what you have here is the limit when x approaches to c of f of x, okay, times the limit when x approaches to c of g of x, and that should be the same. Okay, another one, but you need to be a little bit more careful, is the quotient rule. The quotient rule tells you that the limit when x approaches to c of f of x divided by g of x is equal to L divided by M all the time when M is different than 0. If M is different than 0 and L is a number, then you might have on definition, or what we call does not exist. You might have one of the infinities in that case as well. Okay, so you just need to be careful when the limit of the denominator is 0. Okay, the next one that we have over here is the constant multiple rule. The constant multiple rule tells you that if the limit when x approaches to c of the constant k times f of x that's going to be equal to k times L. In other words, what this rule is telling you is that you can pull out the constant outside and then compute your limit. Okay, this is what the constant multiple rule is talking about. You can do this and then multiply times the constant that you have there. Now, the power rule is if you have r and s integers with s different than 0, then what you have is the limit when x approaches to c of f of x to the power of r divided by s. This is going to be equal to L to the power of r divided by s, given that this is a real number. If it's not a real number, that's game over. Okay, please remember that in calculus 1, 2, and 3 we're always going to be working in the real number plane. Okay, so the seventh property that we have over here is the limit of a composite function rule. If f and g are functions such that the limit when x approaches to c of g of x is equal to L and the limit when x approaches to c of f of x is equal to f of L, then what you have is the limit when x approaches to c of f of g of x is going to be equal to f. Okay, and then you're going to compute the limit when x approaches to c of the inner function, which is g of x in this case, and that will give you that it's f of L. So for this problem, we need to use the graphs of f of x and g of x provided below to determine the limits. Please note that this is f and this is g. Okay, so let's see what we have here. The limit when x approaches to 3 of f of g of x. So what are we going to do? We have that this is going to be equal to f of the limit when x approaches to 3 of g of x. Why we know that this is true? Because of the rule that we just learned. Okay, this is your rule. Now you're going to work inside out. The first thing that you're going to do is you are going to analyze your function g, okay, the limit when x approaches to 3. So you go here, you find your 3, which is here, okay, and what's going on here, you have that that's 1. So you have that this is f of 1. After that, you have f of 1. This is going to be the evaluation of the function f at 1. So you go here, find your 1, okay? So you can see that the 1 is going to be here, which is negative 2, so we are done. Okay? So the next one that we have over here is the limit when x approaches to negative 1 of g of f of x. So what you're going to do here is g, okay, and you're going to find the limit when x approaches to negative 1 of f of x. Okay, so what we're going to do here is you are going to start with the function f, why, because it was the inner function, okay, and then you find where's -1, which is here, okay, and you can see that it's here at -6. So you have g of -6. Now you're going to tell me, okay, so we need to go to the function g, okay, and then -6, and you're going to tell me, hey, I ran out of graph here, I don't have it. Well, you know better. You know that this arrow, it means that it keeps going there forever. Therefore, you can see that this graph is going somewhere there. We don't have enough grid, but you can find the equation of this line. The equation of this line, you know that this is g, part of the g of x, and you have that this is a line, and you can see the rise over run here. You can find the slope that it's +2, okay, and then you can see that if we keep going here, you're going to hit the 5, so that's your y-intercept. So you know that the equation for this line is going to be 2x plus 5. So what you can do here is you can replace the x for the 6, okay, so you can evaluate this equation. So you have that this is -12 plus 5, that's going to be -7. Do you see it? Okay, and why we select this line? Because you know that -6 is going to behave like that line that we have over here, okay. So the next one that we have over here, we have the limit when x approaches to 1 of f of g of x. So similarly to the previous two, you know that it's going to be f, okay, of the limit when x approaches to 1 of g of x, okay, and this is going to be equal to, you have this, okay, so you see the g, you find the 1, and you're like, hey, wait, we have an issue. This is going to be f of d and e. Well, that one is very wonky, so this is going to be d and e, okay. Do you see why it's d and e? Because at 1 you have the limit from the left is going to be -1, and the limit from the right is going to be -3. So they are not equal, therefore doesn't exist, okay. So you have this. Now for d, what you have over here, you have that it's going to be g of the limit when x approaches to -3 of f of x, okay. So you have this. Now what we have here is, you look at the graph of f, okay, you go to -3, which is here, okay. So what do you have here? You hit here -6 again, so g of -6, that we already know the value, that it was -7 from part B, okay. Yes, okay, so that's what we have for this problem. Now for this problem, we have that f of x is equal to x minus 5 and g of x is equal to x squared. They ask you to evaluate the following limits. The first one, you have that it's a limit when x approaches to 1 of f of x. So what you're going to do is you replace the f of x with the actual expression that they gave you, in this case x minus 5. So you have that this is going to be equal to 1 minus 5, so this is going to be equal to -4, okay. So you can see that it's very beautiful because we don't have any issues in this limit, okay. We just pretty much replace the x for the value, okay. In this one, okay, g of x, they are asking you to find the limit when x approaches to 5 of g of x. So what you're going to do is the limit when x approaches to 5, and your g of x is x squared, so you have that this is 5 squared, which is going to be 25, and there you go, that's it. Nice, right? So the last one that we have over here in this little set, we have limit when x approaches to 1 of g of f of x. So similarly to the previous question, you have g and then the limit when x approaches to 1 of f of x, okay. So we already have this because we computed in A. Do you agree with that? So you have that that is going to be g of -4, and then you are like, what is that? Well, you have that g is that, so you just plug the -4 instead of the x, you square it, and you get the beautiful number 16, and we're done. Isn't that nice? Now let's do a little bit more, so you can see that using the properties of limits is pretty nice, okay. So what you have here is, given that the limit when x approaches to a of f of x is equal to 2, and limit when x approaches to a of g of x is equal to 3, they ask you to evaluate these limits if they exist. So the first one that you have is the limit when x approaches to a of 5 times g of x. So what you have here is you can use the multiple constant property here, so you can take out the 5 and then compute the limit when x approaches to a of g of x. So what you can notice here is, even though we don't know the value of a, the beautiful part that you have here is that this guy that we have over here, you can recognize it, that we have it here. Do you agree with that? So what you have here is that you know that that limit is 5 times 3, okay, because this is 3, so you have that that's 15. Isn't that nice? Similarly, in the previous example, that we have in the next example, that we have over here, what are we going to do? The first thing that you can do is you can split this equation, the limit when x approaches to a of 6 plus f of x. And then the denominator, what you can do here in the denominator, you can have another limit because I'll show you in a second. What do you see about that limit? This limit that you have is not equal to 0, so we can apply the quotient property. Okay, do you see it? So you know that this one is going to be 3. But the top, we're not sure. So you take the limit when x approaches to a of 6 plus the limit when x approaches to a of f of x, and all of that is going to be divided by the limit that we have from the previous step. Okay, so you have the limit when x approaches to a of g of x. So what you have so far is that this is 3. Okay, so you are happy. Now we are not sure about this guy, but you see something friendly here. Okay, you recognize that this guy that we have over here, right, that one is the same as this one. So we know two very important things. You have something plus 2 divided by 3. Why 2? Because you can recognize that this one is the same as this one. Now you're going to tell me, what is the limit when x approaches to a number that we don't know of a constant? It's going to be the constant, so you have that this is going to be 6. So the result of this is 8 over 3, and you're done. Isn't that nice? So let's move on to more limits. Okay, so some of the most important special trigonometric limits that we have are the following. The limit when theta approaches to 0 of sine of theta divided by theta. Here the main thing that you want to see is that the argument is the same as the situation that you have in the denominator. This is going to be equal to 1. And the main pattern that you are going to see is the theta. This one needs to be the same as this one. We're going to prove this later in the year, but right now you need to remember this. Similarly, you have that the reciprocal of this expression is this one. What do you think that it's going to be equal to? Okay, so this is going to be equal to 1 as well. Okay, so if you see this or this, remember, theta approaching to 0, that's going to be 1. Now, similarly to this too, but a little bit different, you have the limit when theta approaches to 0 of 1 minus cosine theta divided by theta. This is going to be equal to 0. Okay, so those are the 3 rules that we have for now. Okay, later in life we'll prove it, but right now you need to remember them as rules. So if I ask you to evaluate the limit when x approaches to 0 of sine of 8x divided by 5x, what are you going to do? The first thing that I see here is I don't see the 8. I need an 8 in the denominator, so these two match. They don't match. I have the x, but I don't have the 8. So what we're going to do here is we're going to multiply numerator and denominator times 8. Why we can do this? Because at the end of the day, 8 over 8 is a 1, so you're not affecting all the function that much. Okay, so what you have here is you are going to reorganize your situation. Why? Because at the end of the day, in the denominator, what you have is 5 times x times 8. So if I rearrange as 8x here, and then I have my sine of 8x here, I can see something very user-friendly. Okay, what you can see there is you can see that these two match. Then I put the 8 that I have here, and then I put the 5 here. So what I did here is nothing more than change the order of the 8 and the 5, that you know that multiplication is commutative, so it doesn't affect the resulting situation. Now what you have here is something very beautiful. Why? Because this part, okay, the limit of that part is going to be 1. Why? Because they match and the x approaches to 0. So you have that this is going to be equal to 1 times 8 over 5. And the result is going to be 8 over 5. Do you see it? Hopefully you do. Okay, so the next one that we have over here, okay, because we're using this property, okay? So the next one that we have over here, they are asking you to evaluate the limit when x approaches to 0 of tangent of x divided by x. You're going to tell me, hey, I don't see any of this here. Well, make them happen. I'm pretty sure your pre-calculus teacher, what they told you is that if you see a tangent, cotangent, secant, or cosecant, make it a sine or cosine. So we can make that tangent, okay, a sine over cosine, okay, and you know that from pre-calculus, okay, so sine over cosine, and then you have the x. what you can see here is you're like, okay, so I see very promising things. Do you agree that x is the same as x over 1? So I put that one. So I see very promising things. Why? Because I see the sign of x and the x. So reorganize this, okay, using the rules for to simplify fractions. Okay, so what you have here is sine of x divided by x times 1 over cosine x. Do you agree with that? Now again, what do you see here? Okay, I see another friend here. Again, you see this guy. This guy is exactly the same as we have over here. Isn't that nice? So what happens? You know that that part is going to be 1. So we are happy. Then you're going to tell me, hey, how about the 1 over cosine? Well, the cosine, what's cosine of 0? Why 0? Because that's where the limit is approaching. So what do you have that it's cosine of 0 from precalculus? That's going to be 1. Therefore, technically speaking, what you have is a 1 times 1 over 1, which is going to be 1 times 1, which is going to be 1. Isn't that nice? Well, I hope that you find this video helpful. If you have any questions, please remember to write them in the comments, and I'll see you later. Bye!